All right, so today we're going to talk about data management using the DPLYR package. Of course, feel free to interject whenever you want. Feel free to text any questions that you have or chat. But we're basically going to use this DPLYR package. And I'm going to share my RStudio screen right now. I have to see which version I have. Here we go. Okay, you'll see that I opened up a few things already, including a help file. Do you guys see RStudio within the screen?
Yes.
Okay, super. Thank you. So the first thing we want to emphasize and take a look at is if we look at just tools and then we look at help, we look at these cheat sheets. This is very useful. This tells you everything about the RStudio interactive developmental environment. Great. We're going to talk about data manipulation because last time, or the time before last, we really spoke about importing data. Now what do you do once you have the data? And this is this is like one of, if you look at blogs, I just looked at this, this is like one of the top 10 blogs, packages that people wish they had known when they used it. If we have time, we're going to look at ggplot for data visualization. But this is pronounced DPLYR. I call this tidyr. We're going to focus on DPLYR. And it's sort of like the Mosaic package in the sense that it isn't just one specific package. It is actually a bundle of packages with a particular logic of analysis that is far more intuitive than base R. I've messed around with base R. We could waste time comparing and contrasting those. So this is our plan. We're going to take, if you look at this screen here, I'm actually going to, I created a lot of variable data sets here. You'll see why. I'm just going to clear the console, and I just cleared the environments, and I want to also make sure that we can at least provisionally see our plot pane. We probably won't have anything there. I'm going to clear our history, and we'll keep the files because I want to show I'm working in a particular working directory. Most of what I'm going to be using is this DPLYR and FOSSEE R script. I also, whenever I work, I have something called dross. It's just a fancy word that means junk. If I have ideas or I'm writing script as I'm writing code and I just think, oh, this is a good idea, but I'm not really using it, I put it there. That's something that you might want to think about. If you notice, I also have something called an R project file, which is basically a way of consolidating everything that you do and open in one session. It's sort of like you save so if I closed all of this and I just double-clicked on this project, it would reopen all of these files that I have here, saving these tabs, saving all the script. It's not something we're going to emphasize. I just want to show this to you. But the main point is we have our Titanic data set, which we've seen and we know. We have our problem set 1. We have the DPLYR stuff. Just ignore the rest. And I'm going to show you what we can do with just the Titanic data set. It's pretty darn cool. So let's go to the environment. And I'm going to close, let's see, everything except this junk file and this very familiar script file. So, and of course I can share this, I'm going to share this with you guys hopefully. So the first thing we do when we run the script is we're just going to install the packages. It's going to ask me to reinstall. I'm not going to because I actually installed both of these packages. So I'm installing Mosaic because we're going to use some of the Mosaic tally functions to examine our data. And then I'm going to use the library function and run that. All right. And then I'm going to set the working directory. This is just, again, the path file. You've seen this before. So the working directory, you can just type this here. This is just, it tells you where your stuff is. Create a folder. I call this R, DPLYR, and FOSSEE. Do something intuitive. Keep it consistent. I don't want to emphasize this too much because I want us to get straight to the cool stuff you can do in DPLYR. And some of you who had seen maybe the earlier week had gotten the sort of the concepts here. We're going to talk about filtering, selecting, arranging, mutating, summarizing, and we probably won't get to melting. In fact, we may just get to these. So I'm going to translate this for you. This is the rare time I'm going to use the equal sign. Filtering in plain English means subsetting rows. Selecting means subsetting variables. Arranging means sorting variables. Mutating means creating new variables. Address. And I'm going to show you some new syntax here. Okay, so let's just dig deep into this. And the cool thing is we're going to revisit the Titanic data sets with some of these DPLYR functions. I want to emphasize that there are going to be more functions here and probably more things that you want to do that we're not going to cover, which is why at the bottom of the script I want to show this to you. Here's a nice command called browse vignettes, and you're going to look at the package DPLYR. Now when you look at packages, there are 14,000 plus packages. Vignettes are kind of an indication that the package is actually sort of set a relatively high bar for itself. A vignette, as in English or French, I believe it's French, is just a short story. Vignettes are a godsend if you look at packages. Sometimes you'll look at a package and it might have exactly what you want, but you don't know how to use it. A vignette is just a story that maybe gives you a data, or maybe it's a paper that's been published, and it'll tell you exactly how to do it and it'll walk you through. So I'm going to say if there are unanswered questions, type this in. In fact, why don't we start with this? I'm going to share actually this tab, and I'm going to show this to you. If I can open this, share this part of the screen. I'm going to do a new share. Do you guys see this in the RStudio console? Do you see the web browser? If not, I will do a new share. I'm going to share let's see, vignettes. Here we go. Okay, now you should see, do you see this now? Okay, good. Yeah, okay, so this is very useful. Look at this. I have lots of, I even have my own R stuff. And I have health data. I have the stat heat 100. By the way, this is a good, we'll talk about that later. But the point is, when you type in a command like this for a lot of packages, you'll see vignettes. Probably the best place to start is this introduction to DPLYR. We're going to cover some of this. But look at this. Here they give you lots and lots of different things. They're going to show, lots of things. The thing is, of course, it's not a data set that is actually that interesting for a lot of people. It's not so, it has to do with flights, and you're going to do cool stuff here. But this is, by the way, a different function. But anyway, the point is, vignettes are great. And then you can look at the source. So here's just the actual code, and then you'll get the actual R code. If that doesn't download, you'll see this here. I'll walk you through this, because in all of these examples, I think they almost always use these flights data sets. So keep in mind, like whenever you see here flights, you could actually just do the data frame. And I'll sort of explain this a little bit further. Okay, I think that's the main thing. I would really start here. But the cool thing is there's a lot going on with this. So I'm going to do a new share, and I'm going to take us back to our studio and to our little to our little screen here and get us started. Okay. So let's take a look. So let's do this. Let's see. Did we set the working directory? Yeah. Okay. So we see in our working directory we see our DPLYR code. We see this. We see our Titanic data set. So you know what? Let's load our Titanic data set and take a look at this thing. All right. Okay. This is quite familiar, right? We have this age. We have this kind of stuff. Let's type in the view function in the console if I can do this. View Titanic, and you'll see the tab here. This is what we did in week 1. Now, this is great, but what I want to emphasize here is there's a difference between this Titanic data frame that we upload and something called, with this table df function, it creates what you call a local data frame. And it's not a big difference, but it's a good difference because it kind of adds a little bit of extra information to the data matrix. And you have to define it as an object. But the essential advantage of using this function, this table df function, is that once you upload the data, then you define it as a local data frame. It's just easier to print. It's easier to view. You can use the print function. You can manipulate it a little bit better. I like it. It's just a very simple thing just to get started. And here we are. You notice that here we have the data frame titled DF. Now, what we're going to do when we subset by rows, and then that is filter, and then we're also going to subset by columns and create these we're going to create new data sets or data frames. And when we think about conventions, think about when you define data frames or label data frames, try to use either what is called camel case, which is just capital letters, often starting with a lowercase letter. These are just naming conventions because I'm telling you, I'm going to create a lot of data sets, and so might you. Even though Titanic violates that, a camel case data set would be like data frame. Cool. It's called camel case because, like a camel, it starts off low and then it has a little hump and then it has a little hump. And you can sort of distinguish between, chunk the two words, the words here. But R is also a dotted programming, I think it's called a dotted programming language. The point here is that typically there are some words or names you can't use, but typically you can name things in terms of dots. You can do DF, cool, awesome, and then we're going to just define this as a copy of our data frame. And keep in mind, we're going to use a lot of this function called the assignment operator. I talk about it each week. But if you're not a regular attendee of the sections on the code, keep in mind this assignment operator is crucial because what we're doing is we're taking everything to the right of the assignment operator and saying, we're going to make it new like this. And here's the point. You can make copies, as we've done here. These are identical with the same name. But you can also replace data frames. So I could alter one data frame and then rename it, and then it just overwrites the old data frame. And this is just relevant because when we subset, sometimes we want to keep our source data frame. Because here we're going to take our DF data frame. So I'm going to remove this one here, and we'll keep we'll keep the Titanic data frame. But think of this data frame here, this one right here, this local data frame as our source, and we're going to create a bunch of subsets and a couple new data frames that are relevant to maybe the analysis that we want to do. Okay, and I'm just going to compare. If you look at the class function, class is a function that tells you what kind of object is this. There are different kinds of objects. We don't really go into that in detail, but a data frame is a type of an object. Well, if we look at this, we see that our local data frame has 3 bits of information. We see that it's a data frame, and it has this you know, whatever, this string called table df and then table, but it's just slightly different than the Titanic data frame, which is just a straight up data frame. I'm not sure what that really means, to be honest, except that it does clarify that there are some differences here. And you can see this quite clearly here. Notice we always use the head function or the tail function to look at the first few rows. Well, if you have a local data frame, you can just say, you can print this, and you can just use this using the print function. You have the print function, you have the print, open parenthesis, you have the object, the data frame, comma, and we're going to look at the first 3 rows. And here we are. And this is a little bit different, I think, if you look at the head function, if you notice. In fact, let's actually, what I'm going to do is I'm going to clear the console. I'm going to do Control L. A lot of people don't like to do this. I just like to clear the console because it sort of, you know, clears my brain a little bit. I'm gonna actually do the head of the Titanic, and then we're going to do a 10 here. And if you look at this, there's a little bit of information that's quite different here. First of all, well, the head shows the first 6 rows. Second of all, I'm not sure what a tibble is. That might be a coding term. But it gives you the dimensions of the data frame, right? And data frames are always indexed. Matrices are always indexed by rows, columns, rows, columns, rows, columns. That's just always important. Does anyone know what a tibble is? Feel free to Google it and tell me if you want to put it in the chat box. I don't know what that is. But it also gives you, look at this little asterisk here. It gives you whether it's a factor or, I'm not sure what the double here means, but it seems to indicate some sort of, oh, this could be the way that it is encoded, a double byte variable. It could be the way that the memory stores the variable. Regardless, FCTR is a factor variable. It's a categorical variable. These are numeric variables. Categorical, numeric, categorical. So it's a little bit more useful, and it tells us how many more rows are left that we don't see. So I like this quite a bit. Okay, so here we are. We have our. I'm going to clear the console again. We're going to use our local data frame. In fact, for simplicity, I'm going to remove our Titanic data frame. We can always upload that later. Okay. By convention, I don't know if I'm the only person who does this. I always like to just start off with calling a data frame a DF. So yeah, so Matthias, thank you. He says Tibble, simple data frames, provides a Tibble data frame class that offers better checking and printing capabilities. Exactly. So I guess it's just a little bit of, it's the full name of the actual function. So I encourage you to use it. We don't really talk about it in class. Another thing to do is to use this options command. In class, we talk a lot about rounding because we want to have rounded numbers. If you do select this options function, by the way, there are a lot of options you can pick. You can select the number of digits that you use. Typically, that changes. From whenever I do the analysis, sometimes it looks like it's scientific notation. But for your own work and for at least for illustrative purposes here, I just want to set our number of digits to 2 rather than I think what is typical, which is the default is 7. So that way when we look at tables of proportions, your eyes aren't going to glaze over. So that's a neat little command, and you can just do a query on that if you want to know more about other ways to set your parameters of your working space. The caveat here, of course, is that when you set the digits here, these are going to be different than the problem set answers, especially if we're asking for specific numeric variables. Okay, so we have 5 commands or 5 features here that we're going to focus on. Subsetting rows. When would you want to subset rows? Well, maybe you're not interested in all passengers. Okay, I'm going to delete this. I was making a lot of notes about what you do in base R. Base R is what I'm used to. It's the clunkier way to do things. But take a look at what we're doing here. Here we're doing when you use DPLYR, especially when you want to define an object. By the way, if you don't do this operator sign, you can manipulate everything all you want, but you're not going to save a new data set or new data frame. And I would recommend, if your goal is to actually create a new subset data frame, do that. And you can save quite a few actually in R. So that's the nice thing about it. And you can transition between the two. So the first thing I want to show is the elemental syntax of many of these commands within DPLYR. You're going to have the code here, and then you're going to have the data frame. So this is the name of the data frame that you're going to manipulate. And here's the cool part. Unlike the formulaic expressions in Mosaic, we don't have a tilde or anything like that. In fact, all we're going to have is we're just going to have the variable names. And we're going to have some equal or less than signs or some other sort of algebraic operators here. And I want to emphasize that if you look at the cheat sheet, welcome. I see there's perhaps another person joining us or someone rejoining us. Okay. If you look at the logic here, you can see some of the signs here. But the main point is that if you're going to define something by certain criteria, take a look at the logical operators in the cheat sheet. And this is the first page right at the bottom under subset observations or rows. And this is important, but it's also extremely flexible. So what I just did here is I'm taking our data set, and let's remind ourselves of the names of the variables in the Titanic data set, if we just forgot, right? So here we have 1, 2, 3, 4, 5, 6 variables. What I'm deciding to do, unless you have any suggestions, feel free to be flexible. I'm going to create a new data frame called df.boys, because the dot doesn't do anything, but it makes it readable. And I'm just describing, whatever you do, just make it consistent. And I'm saying I'm creating a new data frame of boys, and I'm going to filter. So I take the original full data frame, and I'm taking the age variable, and I'm saying I'm going to keep you if age is less than or equal to 18 and gender is equal to male. So if you notice, for the factor variables or categorical variables, the values are in double quotes, and this assignment operator is a double equal sign, because you're saying gender, I am defining it as equal to this. So this is, you could do this, create this data set. Now, you could tack on within each comma as many options as you want. You could do, let's say fair, yeah, is greater than, here fair equals 0. I don't even know if well, you know, you can do things like that. We won't do that for now because I know where this data set's going a little bit. So let's take a look at this. Well, what you see is now you have a new data frame, df boys, that you can now manipulate in a different way. So, you know, you can do the same thing that you did before. I believe because the first one was a local data frame, this is also a local data frame. I could be wrong though. Let's take a look actually. Class df boys. Yeah, okay. This is the nice thing about this. You're because all you're really doing is subsetting the data frame. You're not doing anything else. You're by filtering. But the point is, now we can take a look at, you know, compare df boys, say the proportion of those who survived in our boys data set compared to the actual full data set that we did for class. So let's take a look at first at the full data set. Keep in mind, I used the options before, and that remains throughout the whole session. So we're going to see 2 decimal places. Well, what do we see? Well, we see that the 64% of the upper class sample in total survived. Okay, what about if we just look at those 103 boys, the 4 boys in the sample? Well, you actually see interestingly, a slightly larger gradient. 75% of upper class boys survived. So, you know, here's a great example of a few filters. You know, someone asked about the Titanic data set, and I thought, well, maybe it isn't that interesting. On the other hand, take a look at this. You could, I don't know if people have even looked at kids on the Titanic or, you know, other factors. So you can take one of our data sets and filter and look at survival rates. And, you know, for example, does gender matter when you're a child? That's kind of an interesting question. I don't know. And you can do that. Okay, I'm going to introduce another concept here while we're doing this. And this is one that's going to carry over across other functions. This is called the pipe. Oh, sorry, not the pipe function. I'm sorry. I'm thinking of chaining. Sorry. So the pipe function is an OR operator. So we might want to say, so this is a little bit different than Mosaic, right? Mosaic, we did the tally function, and it was like the first variable conditional, which is the pipe, on the other variable. Here we're saying, let's just create a data set, a data frame of the just middle and upper class people. And that's what I did here. I basically said, okay, we're going to filter, and here's our object, our data frame. And we're going to say, what happens if you just keep people who are in middle class or they're in upper class? And that's it. So that's just an example of another operator here. And here you can actually see the output here. If we just look at the mid.up. Notice as there's some logic to these data frames themselves, right? So we have data frame mid-up, you know. It's not always easy to keep track of this, but look at this. Here you see, actually, interestingly enough, oh, interesting. So it will keep, this is interesting. This is because I subset, remember what filter does. You're dropping rows. You're not dropping columns. So we still have the column lower, even though it doesn't exist. So this will actually take us to the next section pretty soon. But keep in mind that sometimes, more often than not, we want to combine both dropping columns or values of columns and then rows. And here's a good example where, for instance, you know, we have some interesting proportions, right? Still seems like class matters, but we don't really want to have this lower class variable here that is just sitting in our data set. And by the way, that's what Hadley Wickham would refer to as a not very tidy data set. If you look at the cheat sheet here, a tidy data set is one where every column has a purpose and every row has a purpose. You know, why would you have empty columns? Are there any questions about our first filter variable? Otherwise, I'm going to use the filter variable, but I'm going to introduce a new concept called the what is it called? The chain operator.
I have one question, Nate. So,
yes.
I was using, when I was testing this DPLYR package, I was using DPLYR filter.
Yes.
Is the same function that you're using now, because you're not writing like DPLYR package before? There is any difference between these two methods?
I am using the DPLYR package, in fact. Right? So all of these functions that I'm using are in the same way that the tally function, for example, that we use is required as part of the Mosaic package. These functions here, these subsetting functions, and the logic of the syntax is structured under the DPLYR package.
Okay, sorry. So I was writing explicitly like DPLYR before the name of the function.
Oh.
I put it in the chat. I was writing it like deployer to.
Okay. Yes. Okay. Sure. So
It's not necessary.
it isn't necessary, right? I mean, you could. I'm not sure why you would want to do that. Maybe just to be more specific. And in fact, to clarify, if you look at the worked examples that they provide in the cheat sheet, that's what they do here. So I'll show you how to do that. That's relevant. So, for example, and I also want to show you, by the way, if you don't define something as an object, if you just want to filter, like I do here, okay, here I printed out the data frame, but I'm not defining it in my workspace here. So even though you can filter and you can manipulate data frames, you want to make sure that you're defining it as an object that you can save. I just want to make sure that you emphasize that this is why the assignment operator is relevant. So yeah, so what you did is you did right the DPLYR, and then there's 2 colons here. Now of course this isn't going to make any sense because I you know, have this here. I think I can let me see if I can detach. I forgot how to unattach. See, I don't even know how to uninstall a library because I'm so used to actually just installing packages. But this is why we have a GUI method, right? We have DPLYR here. Well, that's interesting. Okay. Okay, so I thought I typed detach. Oh, you might have to perhaps unload. Okay, so it looks like DPLYR. So this is an interesting point, guys. Actually, I didn't know this. So because Mosaic invokes a lot of other packages, we actually have DPLYR already installed when we use Mosaic. So we actually have to detach Mosaic as well, because we can't. This is probably why I ran into that error, but for some reason this is I want to detach. Let's see if I can. So that I just want to see if I can detach everything here. So it looks like why isn't that showing up? PLY. So it looks like these are not actually installed. Let's just confirm this to be the case. Let's try to actually let's try to filter without this option here, and we should get an error message. No, okay. All right. So anyway, Matthias, the point is, yes, you don't have. From my experience, because I'm so used to using Mosaic, you don't have to do this little bit of script beforehand. In fact, I would think it's rather tedious. But if you find sufficient motivation to do that, by all means, because a lot of people are used to using base R, and that's what the examples show. Anyway, let's just move on. I want to make sure we cover all the material. So if we go to our environment, we defined a couple data frames. We have boys, we have this. I want to introduce this this chaining operator, and what this does, it's called piping, and this is where I got the pipe. So to be clear, this little thing here is called a pipe or a vertical bar, and in the R environment, you can pass arguments using piping. Oh, do we do that here? Oh, we'll do that later. Okay. What this does, okay, so there are a couple other functions here before we go to piping. I just got excited about it because I think it's a lot of the work that I've shown is how to nest functions. And what piping does is I think it provides a more elegant framework for passing arguments. All this does is this says, this is just one of the logical operators that is provided in R that basically says class is in the group of lower and middle. And this is the combine function. I've talked about this before. What I'm trying to clarify here is that I'm going to get rid of this. That I'm going to actually make these identical. There are, like a lot of things in R, there's more than one way to filter or subset, which is kind of vexing. And I'm going to define this as two. So you can use this OR function, this pipe or function, or you can use this in function, this grouping function. All this says is well, with this, I'm creating a data frame using this larger data set defined by the variable class, which is grouped by these two categories. Now, sometimes this is a little bit easier because look at these equal signs. You have to write a lot. This is more text, actually. The combine function is quite common. And in fact, we could even define this as an object. We could say values, I believe. You could actually define, it's very common to define something like this as an object, just a list of elements or values, especially if you have a ton of values. Let's say you have 10 counties, 50 counties. That's sometimes easier to do. You just want to say, I want to keep those that are in the group of this. Okay, I'm talking a bit too much on this. Any questions about that in logical operator? It's not a big one. It is less common than I think these others, which are greater than, less than, not equal to. That's a bang equals. It's often called a bang. So you can say I want to just keep everything that is not equal to the age or that is not equal to upper class, for example. Okay, can we move to the next ones to selecting? So these are columns now. All right. So we're gonna, more often than not, you're gonna encounter more variables than you care to be interested in. It happens all the time. So how do we deal with that? I don't typically like to name, by the way, data frames with numbers. I don't always do it. Sometimes I'll use it to index like a copy, for instance, because you also want to balance the fact that these names are shorter. But what I'm doing is with the select function, you're going to see something very similar. Well, look at this. Here we have the data frame. So here we have the select function. Then we have the actual data frame we want to select from. And then we just have variable, comma, variable, comma, variable. Pretty simple. You can identify the variables you want to keep. And I just define this as one with 3 columns. And you can see this right here. Here's the data frame with 3 columns within RStudio. You can just click this little tab. Here we have gender, fair, and whether or not they survived. So that's quite easy. Now the other thing is, let's say you want to keep like a set of variables, like the first, I want to keep, for instance, if we do the names of our data frame, and I want to say, I want to keep all the variables from gender all the way to name. This is more important when you have 100 variables. You can use this colon operator. You're just saying, I want to keep everything from here to here. I call it the first 3. And in fact, this is what you do, right? Pretty straightforward. Okay. You can also use this thing contains. So let's just say you have a variable name and you want to have a variable, and by the way, this can be more complex. There are things called string irregular expressions. These are string functions. A regular expression, if you haven't heard about it, it's primarily a way of manipulating um, text. So a regular expression might be like, let's say we have Smith, we have Johnson, Smith, Sam, Susie, and then Joe, right? A regular expression is a way of parsing text so that, let's just say you want to keep those values that start with S, for example. Or maybe you want to keep those strings that only have 3 characters, and that would be Sam and that would be Joe. Regular expressions is just a general term. It's vast, but it's a very flexible way of selecting text by different criteria. I did something very simple for us. If we look at the names of our main data frame, I thought, well, look, I'm just gonna select those that contain the letter E. There's no logic here, but you can just see that just to show that you can select on a regular expression, the most simple of ones. Which one did we drop? Well, we can see that we dropped class, right? And what it does is it reorders those variables. So it just pushes one over. And this is also an important issue. When you do the filter variable as well, it doesn't maintain the integrity of the order of the variables. There's no identifier to go back to variables. You would have to actually do a more complex melting or a join by function. So for example, in this data set, we could join by name, right? We could do something like that. And that's what is called a unique identifier. So that, just to be clear, even though data frames, if you print them, they'll often have this first column here that has a number. That number is not encoded in the data frame. So whenever you subset by columns, whenever you select columns, or when you filter by rows, at least when you filter by rows, the indexing does not matter. Also, when you filter by columns, the order of the variables do not change. So those are things just to keep in mind. Okay, I want to talk about this thing called piping or chaining, pipelining, I suppose. I also see it as piping here. Think of it as the word then. What is it? It looks funny at first, right? It's a percent, and then it's this little caret sign. This percent is greater than this percent. But what does this mean? It means then. Think of it as the English word then, or Latin ergo, or Spanish por eso, I guess you could say, right? So what do you say? You say yeah, it's also called the infix operator. But think of it as then. And what do you do here? First, I want to just emphasize that what you have to do if you're going to define a new data frame is you're going to have to do all the DPLYR stuff you do. You have to encapsulate within brackets because you want to create a new data frame. And here I'm just going to create a new data frame that I call data frame chain, which is just an illustration of chaining both selecting our variables. Oh, sorry, I take the data frame, then I select the variables I want, then I select the age group that I want by some logical operator. And of course, I can include many. So here we are, basically reshaping or restructuring the data frame. And we're calling it df.chain here, simply because it's an illustration of combining two important functions that you're going to have to combine in a very effective and kind of elegant way. And, just think of it as a sentence. So I'm defining a new data frame called df chain using df. Then I select these variables. Then I keep only those observations where age is less than or equal to 18. And so that's what we do here. I'm just going to highlight this, and we have that. For readability, if you notice, I keep these brackets for defining the objects roughly equivalent. I also indent a little bit the functions that I apply to this the major, the sort of the source data frame, it's readable. And if we highlight it, you can sort of see they line up. So that's just a little bit of syntax here. So now let's take a look at our new data frame, huh? If we take this and, oh, sorry, and we look at our, I uninstalled Mosaic. This is what I did, or I detached the Mosaic package. That's interesting. All right. I just want to show that, you know, you could take this data frame, you can apply the age here, and you do find something novel here from this new data frame, right? You can see that if you look at survival rates, you actually find that those who survived had a lower median age than those who did not survive, even children. I thought this was really interesting. The maximum, of course, is 18, and the minimum is 0. But the median is different, and the mean is larger of the children who died. This got really depressing, to be honest, when I was looking at this. But it's a clear, and by the way, if you look at the variation, it doesn't seem to vary that much, nor does the N, right? It's about a 50-50 ratio. But you actually see what happened. Well, you see you see younger children, women and children, I guess you could say, younger children seem to survive more, had a greater likelihood of survival. Now that, of course, then you could ask questions like, is this confounded by the fair, by the social class, by gender? Were there older boys because they had other purposes, right? You have a research project here. This is a good final project. Okay. Sometimes, now I don't really see a good example here why you might want to do this, but let's take a look at our data frame here. I'm going to just use the view function. But sometimes you want to order or sort all of you. This is sort of like in an Excel. If you sort by one column, you're going to sort all the other variables as well. This is the arrange function. You're going to just reorder the rows by some, again, by some logical sequence. So if you just take the analysis here, well, here, I'll show you what the data frame looks like. We'll print the data frame, the first the first 6 rows here. Yeah. Do I want to do that? No, I want to print this chain data frame, right? Because this is unordered, and you'll see. Well, looks like it actually looks kind of sorted here. Oh no, it isn't. It obviously isn't sorted. So you have 14 here, and then what we can do is, in fact, let's do this. Oh, we won't do that. We'll still use our source data frame. But keep in mind, you can take data frames that you subset and then arrange those and sort those. You can just create, nested data frames. But let's use this, define a new object as data frame arrange. And I'm going to clean up the syntax so this doesn't look that good, and get these to line up, right? And again, what we're doing, we're piping or chaining our syntax, right? So we're selecting these variables, and then we're doing one final thing. Instead of filtering by age, we're going to sort by age. And you know what I'm going to do? I'm going to add a pipe that actually will also filter too. Why don't we just pile it? Why don't we pile on these commands? I call them commands sometimes because you use that in language and standard stats package, but these really should be called functions. And everything that's a comma between each bracket is an argument. Think of those as like the words in a sentence, and a function is sort of like this actual sentence. Okay, so we're going to define a new data frame as a range. This should be okay. And it looks like it worked. And notice this, I point this out quite a bit. This little caret here, this tells us, this is sort of like our DOS prompt. This tells us we're good to go. We can start a new command. Whenever there's a plus sign, it means your console is evaluating your function. And if you're ever stuck, by the way, like some people have, like they have, let's say I didn't have this closed bracket, and you see a plus sign, just press on your keyboard escape, and you will go back to your prompt. Or you could just finish evaluating the argument, evaluating the function. Okay, so let's print these rows, and we'll see. Check this out. Here we have a data frame where we have actual, even though, so take a look at this, right? Because it's a data frame, you see the same index of rows, but now they're indexing different observations, and you're sorting them by age in one and not the other. Now this is actually perhaps not as relevant here, but keep in mind you can sort by many different variables. You can sort by year, month, you can sort by year, and then within year you can sort by month, and then within month you can sort by day of the month. And so you can do more complex sorting, or you can sort within groups. So a range is actually, relatively important, even though this example isn't that great. Okay, so now we're going to go to mutate. I don't know why they like to use mutate here. Okay, just totally curious. Okay, so I want to direct you right here on the what I'm going to show is we're skipping some things. We're skipping the reshaping of data. You might want to do that if if you ever played the game Tetris, you can reshape a block in a different shape. You might want to do that if you want to transpose rows and columns, rows and columns. There are a couple arguments there. But if you go to the second page, and you go into your cheat sheet, you look at make new variables. This has more commands, or more, you could say, subcommands than we actually have, time for, really. But I will show you how to basically do this with, I guess some source variables. So let's say we want to compute one variable and append it to some other columns. So let's see, what do we have here? Okay, I'm not sure what that syntax is. So in our data set, for example, let's just say we don't exactly have a great set of variables that we can actually sort of create as combinations. I was trying to think about this earlier, but if we look at like print data frame, we're going to look at this first one. This is more like, if you think about mutate, sometimes it's more useful if you think about, I'm not sure, maybe variables where you want to create a ratio or something like that. But if we want to do, we'll make a sort of a silly example. We'll just basically make a data frame mutate where we define as the object, and then we're going to basically use the same syntax, right? So we're going to, copy and paste here. We're going to take our data frame and we're going to just apply using the chaining function. We'll keep it simple. We'll select these variables. We'll arrange by age. And then we're going to, it doesn't have a closed bracket here. That's why it's complaining. And then we're going to add to this. And remember, you have to do this then. We're doing all of this. And then we're going to add to this mix. We're going to add a new variable called where we mutate. Oh, wait a second. I think you might have to do this separately. Hold on for a second. I'm sorry. I just want to be sure I'm doing this right. Okay. So you have to, hold on for a second. I think with mutate, because part of what you have to do is I don't think you can actually do it while you, I think you have to define the variable, the new variable that you create, and then you have to incorporate it back into the data frame. Right, okay. Yeah. No, you could do this. I think we can do this. I'm not sure because I haven't done it with all these piping functions. I did it by itself. Because remember, mutate, it's a sub-argument. You're actually taking the data frame itself. Heck. Let's start it off easy because actually I'm a little ahead of myself. Let's just say we're going to do data frame mutate, and then we're going to create a new variable that uses the data frame, and then we're going to hold on. Why am I, okay, yeah, no. Mutate, and then we're taking the data frame, yes, and then we're saying, right, we mutate the data frame, and then we're going to define as a new variable, we're going to say ratio, and then we're going to use the equal sign. So this is, we're not going to use the operator, and we're just going to make this as a rather ridiculous ratio. We're going to make this the ratio of fair divided by age. I'm not sure what that would mean, but think about when you do cross-national data sets, you might want to do the ratio of, I don't know, poverty, per population. You might want to do hormone ratios. You might want to do something like that. You can also do other kinds of operators as well. You can, multiply values by something else. You could do, we could actually even standardize this. I think. I don't want to mess around with this, but I bet you could use a standardized a z-score function here if you want to create a z-score. Okay. But the point is, here we have a new data frame where we mutate this variable, and we just make it as a function of others, and we define it as a, first, like the other functions. See, I'm not doing it with a piping function, but if you look at, for example, if you look at the select function by itself, you have to define it with the object. So you may not have to do it when you use the chaining, when you chain this, but we'll take a look. Where were we now? Oh yeah, okay. So here, and yes, okay, here we are. So here we have df mutate, and here we have this weird variable ratio, right? So it automatically melts or adds into that data frame that variable. So we can do head df, so we'll print this, print df mutate n equals 5, just simply to show. Does it show all of them? Why doesn't it show? Oh, interesting. Okay, there we go. So here's the thing with RStudio. If it's not wide enough, it won't show the variables. But what I want to show this to you is, where does it append the new variable? It sticks it to the right. It'll just add it there. Now you can reorder or rearrange the columns as well as the rows, and that's another way to mutate, to change things around. But the point is, there are a plethora of different alternatives you have here. Okay, so I had a little moment of self-doubt. I no longer have that. I think you can, I don't think you have to specify the data frame here. I think you can actually pipe this in. I would be disappointed with Hadley Wickham if that were otherwise. So let's just see if we can create our new mutate data frame by we're going to pile on our commands. And, what do we not have? We don't have our variable fair here. So let's keep this here. Okay, so here we exactly. So we're back on solid ground here. So if we do print df mutate n equals 5, here we have a new data frame where we have, created a new variable. Check this out. This is shows the idiocy of creating this artificial data set. INF refers to infinity because our ratio is a variable defined by 0 or divided by 0. Well, you can't divide anything by 0, so it'll evaluate that to an illogical number. So mutate also has a bunch of other functions that we don't have time to talk about, but I just want to emphasize that there are plenty of ones to deal with. Again, if you look here, you can see that there's one where you can look at the minimum, you can look at the percentile rank, you can look at the row number. Yeah, so that's also another thing that you can do. Let's actually, why don't we try that? Why don't we try some of the, there are enough functions here. I actually haven't even used all of these, but if we do percent rank of variable x, let's do percent rank of h. Let's see what that looks like. I called it ratio still, it doesn't matter, but df.mutate, I should always just print this. You can just type it out, by the way. I don't have to type the print function. Yeah, so here you have, I guess, the percentile rank. Let's just make sure we got fab. If we have fab, let's use the fab stats for function. So there are a lot of different ways you could go here. I just want to give you a couple of mentions here. You have the maximum, you have the cumulative maximum. So, as you add up the rows, let's say you arrange countries from largest to smallest, you can get the cumulative, population as a variable. You can get lagged variables. That is, if you have multiple years, you can get the previous year. You can have different categories. We can do the percent, bin age into like 5 different categories. The 20th percentile, 30th percentile, or 2 groups of the 50th, higher 50th and lower 50th. It's a new data set. Fab stats. I just want to do the fab stats. I just want to look at what that. I wanted to look at that because df mutate data. We don't have any groups, so let's just look at look at our silly we're still calling it ratio. So I'm not sure why the percent rank is maxed out. I was looking at this because I thought it would range from 0 to 100. I'm not really sure why. Who knows? But the point is, let's be clear about what that is. Yeah, no, it's rescaled to 0 to 1. So maybe there's something in the scaling function that, that's sort of one of these many details to look into. But there are lots of ways to mutate these variables. Okay. So we got mutating variables. All right. At the very least, this is where I got us through. I got us to, let's see, set our working directory, filter by subsetting rows, subsetting variables, sorting, and creating new variables. I will cover the summarizing and the joining later on because those are actually crucial elements that are a little bit beyond what we did. And I don't know, I'm doing some stupid typo. And also remember, we're doing, you can pipe these functions together. And piping is actually very useful because a lot of the functions I've done, we nest, and we don't have to we don't have to always nest everything when we round stuff. We can always pipe it. It's just an easier way to read stuff. Any questions, guys?